I'm going to talk about the Wesnoth animation engine. I've been working on the Wesnoth since 2004, and the Wesnoth animation engine is really my main code contribution. When I started, it was really just moving units a little around, and now it's way more powerful. And while I was developing it, I discovered all sorts of interesting things about how to draw image on your screen. So it's a bit more complicated, but for the purpose of this call, of this talk, what is an animation? An animation will be just a series of frames, so JPEG images, JPEG, isn't there PNG images that we have with Wesnoth and that we draw on your screen. How do we display them? In what order? There are some very complicated stuff around to try to draw the screen correctly. And when? That a whole, I'd say a good half of the animation engine is about deciding what animation we are going to play for a given event. So, as I said, the three problems is, we have an event, like unit A attacks unit B. What animation are we going to play? How do we choose it, according to what criteria, and how to have something that's powerful that allows our artists to have all sorts of funny stuff going around. The second job we have is displaying the animation itself. We'll go a bit into how to draw on a SDL frame buffer, just the problem we have with that and how we solved it. And the last problem, which is really interesting to solve, is how to synchronize. When we have a unit which is here and attacking a unit there, we've seen it will slide, hit, and go back. So we have one animation which is logically part of this unit, and one animation which is part of that unit. And those two have to be synchronized. Wesnoth has more than 200 units, and each unit has a couple of attack animations. So we cannot work by looking at every combination. We need a way to make sure they work together without any look at every single animation. So, first problem, we'll see when are animations triggered, why will the engine trigger an animation, how it chooses its animation. We'll see the whole breadth of criteria you can use to define precisely what sort of animation you want, and we'll do a quick review of some fun stuff you can do with that. So here we have the list of all the animation triggers. That's basically the entry points in the code. It's a place where the Wesnoth engine will call the animation engine and tell him, this is what's happening, now you need to draw something. So the first one is before an attack. So it allows some units, most units don't have that, some units to do an action before attacking. For instance, we have drakes, which are half man, half dragon, basically, and some of them attack in flight. However, they stay on the ground when they do nothing. So they have a lift-off animation that they play before the fight. Then the attack animation, which is the animation we play while the units are sliding towards each other. We have the chef animation, which is for the same drakes to land. Victory is played by a unit while the other unit plays its death animation. Death animation when you die. Defend that you play while you're being attacked. Some units have a special ability which allows them to give bonus to other units when the other unit is attacking. So they have a leading animation in which they will draw their sword towards the sky in a sign of leadership. Other units can give adjacent units a special bonus when defending, so they also have an animation to show that they're actually doing something. You have an animation that is played when you're being healed, and another one when you're healing. One of them when you receive poison damage, and then you have the animation when you are recruiting and where you are being recruited. Because when I did my demo, you probably noticed when I was recruiting, the unit will appear white and then scroll back to its normal colors. that is an animation like any other. It's just the default one. But you can replace it with anything, and internally there is no difference between the default one and the real one. Just they're not generated the same way because we fill in the gas. And then you have leveling in and leveling out. Leveling in, when a unit levels up, we play the leveling out animation, which is unit fading to white usually. Then the engine will swap the old unit with the new unit, and then we'll call another animation from the new unit to fade from white to its normal color again. A few more. So we have one before we start moving, again, so to allow our brakes to lift off before they start moving. Then you have the animation while they are moving. Another animation, which is called teleport animation, when they are moving but magically jump from one hex to another adjacent hex. We have a separate animation for that. And then we have the animation for landing. One idle animation is used when the unit has been doing nothing for some certain time. So you have some unit that will dig a worm out of the hole of the ground and eat it. Other one will juggle with knives, I think. I think it's not on that.
And the skeleton juggles his own head.
Oh yeah, the skeleton juggles his own head.
Only happens if there's no problem standing next to him.
Yeah, we'll move to that point a bit later. You have the standing animation, which is the animation which is played when nothing is happening. So some units you will see have breathing movements. So that's the standing animation. And then you have some special animations. Selected animation is played when you click on a unit to show that the unit is being clicked. And you have a ghosted animation, which is for the planning mode when you tell a unit, I want you to move there, but not right now, I'm just studying what I'm doing. So those are technical animations. They're still part of the engine. And last, you have animations that can be triggered by the scenario and scenario events. So we have a lot of events that can trigger an animation, and we have to choose. The problem is we have to compose with the real world. This is a project that is run and done entirely by volunteers, and this includes all our artists. So we've seen that there are lots of animation. It's basically impossible to provide all the animations for all the units. So basically what happens is that an artist will play the game and say, oh, I am missing, it would be fun to add an animation here. And so we will have some units which will have all sorts of animations, sometimes for very special cases because it's fun, and other animation which will have much less. So we have to have a good system to choose the best animations depending on circumstances. So to do that, each animation will display how it wants to be played. Like, I am an animation that only works on that type of terrain. Typically, a swimming and movement animation will work only on water. So we take all the animations that could be played at this particular moment, and we give each of them a score. Basically, the score is +1 each time you match one of your criteria, and the image is entirely discarded when you don't match a criteria. So a criteria can have 3 states. It matches, it does not matches, it's not here. So it means that if I stay with my previous example, we have movement animation, which say I can be played whenever the unit moves. And then you have a swimming animation that will say I can only be played on water. So if I'm on water, one of them will have a score of 0, and the other one will have a score of 1. So the swimming animation will be played. Now if I'm not on water, one of them will have a score of 0, and the other one will be discarded, because it said it wanted to be played on water, and we're not on water. And between top scoring animation, if we have draw, we just choose one randomly. So typically, so that's an example of what I've just said. If we have 3 animations, one with no criteria, one which is used only when fighting elves, and one which is used only when fighting in forest. So if we are fighting a human on mountain, we're not fighting elves, we're not on forest, so we'll have the first one. If we're fighting elves on mountain, then we're fighting elves. So no criteria is not as good as fighting elves, and fighting in forest has been discarded, so we'll use B. If we fight humans in the forest, it's the reverse. We'll discard B. A won't have top score, so we'll play C. And if we're fighting elves in a forest, that's when it gets interesting, because we have two valid ones, and there is no real way to say which one is best. So let's run that. We'll take B or C. Now I wanted to show you a bit the large variety of criteria and how we can really do some funny animations for special cases. So the first one to apply to it's basically how we were told. What event trigger? It's the most basic one. Value, we have some even type specific integers which depend on how we're told. So again, if you want to have all the details, you have to go to the documentation. And then we can do filter per parent type. We can use anything. We can filter on the unit being animated. When there is another unit on the second unit being animated, so you can filter on the unit that was used to attack. So you can reuse your animation for multiple units, but you can also filter on the unit being attacked. You can filter on anything on any of these units. So if they are full HP, you can have a different animation when they're wounded. If they face north, you can have a different animation than if they face east. You can do anything. So direction is redundant, but it's here too. Frequency will randomly fail your animation. So it's allowed to tweak when you want to have a very rare special animation. You can filter on the attack used and on the opponent's attack when you're in attack animation. You can easily filter on whether your attack hit, miss, or kill the opponent. And you can add constant to tweak the scoring for some special cases. So here are a couple of things we can do with it. No retaliation blow. If I am attacking with a melee attack, and the opponent doesn't have a melee attack, as I've explained in my previous improvised presentation, there will be no retaliation. You can detect that and do a special animation for that. So if I take a quick example, here we have a dwarvish berserker, and he's fighting a dark adept. Dark adept have two ranged attack, but they have no melee attack. Berserker have a special power called Berserk. What that means is that the attack will not end until one of the units is dead. So in this case, it's pretty handy because the other one can retaliate and will fight until his death. So here we've seen some selection criteria working. We have a pre-attack animation that makes the dwarf laugh when he detects that he's attacking a unit that cannot retaliate. And then we have the normal animation going on. So it's a good example of having special animations because an artist somewhere had fun and wanted to do something nice. So he arrived and told me, hey, I want to do that. Can you change the animation engine to do it? Well, the animation engine can do it. Something we could do, I don't think there are many examples with Wesnoth, is finishing blows and fatality. We can detect when we're killing and not wounding. So we can do special animation. We can do water fighting, having different attacks when we're underwater. We can have fire attacks that burn people. We could have recruiting animations that are specific to some units. An example would be if I recruit a skeleton, we see it raised from the grave. That's because the skeleton has specific recruiting animation. We could do a different animation if the skeleton is recruited by a mage or by another skeleton. If I kill a tree with a fireball, it burns down. If I kill it with a sword, well, bow, got it wrong. It falls back. Here we have a unit which is flying over water, but if I bring it on the ground, it lands. If I bring it back, it flies back. And if I go ahead and show you that here it lands, lift off, lands. So we have really a lot of choice in what we can do with animations, and it's really rich. I mean, I think our graphic developers don't really see how detailed they can be in the criteria and special animation, but that's a good thing because it means that they start by filling the important holes first instead of going directly to the very detailed animation for very specific animations. But they could. So timing animation is a very complicated problem. Basically, the idea is that when two events have to happen simultaneously, it's very important that they do, because if they don't, it really looks wrong. I mean, if you take a real-time game, being a platform or a real-time strategy, you can have 100 or 200 millisecond timing errors, because you have lots of things happening simultaneously on the screen, and your player is not focused on what's happening. We don't have that luxury. Our animation must be perfectly timed, or it really looks wrong. So this happens when you have multiple animations that are interactive. So typically in a fight you have the attackers, the defender, leading units on the attacker, leading units on the defender, resistance units on the attacker, resistance unit on the defender. That's the worst case. We can have 6 units interacting. So we have to find animation, place them simultaneously, and synchronize them. And as I said, it's always the center of the attention of the player. So to show you the problem, I'm going to talk a little bit about another game called StarCraft 2. I assume most of you here have heard of it. It's a real-time game which is very fast. Very fast because the players are very good. So there are some things in the animation engine of StarCraft 2 that you can observe that are very interesting. If you take a typical StarCraft 2 scenario. You are a human player and you have marines that are dropping on another human player. The other human player will retaliate with marauders. You will immediately grab your marines and put them back in their medevac. Okay. Marines use machine guns. Machine guns are instantaneous. Marauders use propelled grenades. And you can see the grenades fly across the screen when they use it. So there is a time between the moment when the grenade is fired and the moment when the grenade hits. Problem is, that time is, I'd say it's about 400, 500 milliseconds. And top level StarCraft player has like 30 effective action per minute. So that would be, and that goes to real clicks at around 100, 150 clicks action per minute. So what that means is that when you have this grenade flying, the time the grenade flies, the player has taken multiple decisions. So you cannot lie to the player about timing. And the StarCraft engine is completely fixed. There is no randomness. When a grenade is fired, it will hit. Always. If your unit does that many damage per second, it will do that damage. There is no question. So if you grab your units and evacuate and there is a grenade flying, that grenade must hit. But the unit is not there anymore. But it did hit. The unit must lose its hit points. So how do the StarCraft engine deal with this? They do everything. They have the game layers that takes the decisions at the time when they happen. So when the grenade launcher launches its attack, the unit is dead. And so if you evacuate while the grenade is flying, your unit is dead. You cannot. It won't go into the medevac. It will take its grenade. Yes, but what if you could have taken one more unit because if you knew that this unit is dead? So so the animation engine needs to show you immediately that your unit is dead. So whenever the grenade is fired, and before the grenade actually reaches its target, you will see the unit die and explode. It looks wrong. I mean, when you look really, it's okay because it's a real-time game. It goes very fast, and it's hard to notice, but you will notice stuff like Marines dying before being hit. You will see stuff like all the probes evacuating a nexus before the nexus is destroyed, and all this is because you have the game action and you have the animation engine, and the animation engine is timed only by the game action. When something happens in the game engine, the animation starts because the player needs that to react. But that's the only way to avoid that problem. The player needs to know immediately. You cannot have false real time and the grenade flying, the marine shooting, but it's not really shooting because it's dead, and it cannot be evacuated because it's dead, but it looks alive because you can't do that. So they do it the easy way. They have no synchronization between animations. They have only synchronization with the game engine. But that's fine. That's what they need to do. So Wesnoth is different because we have only one thing happening at a time. Everybody's looking at the unit that is currently playing, and and we don't care about time because, as I said earlier, you have time to make yourself a cup of tea in the middle of a Wesnoth game. So no real problem of timing of decision making. So how do we do that? Each animation is described independently and based on a common clock. And the idea is that we have a convention that says that at this time of the clock is when a given event is supposed to happen. So typically for attack animation, they will start at a negative time, like minus 200 milliseconds. They'll start playing, both basing their animation on a virtual clock that starts at minus 200 milliseconds, and they go on until the end of both animations. And they will reach 0 at the same time. And everybody agreed that 0 is the moment when the attack hits. So you have at time 0 is the moment where your orc that's being hit will do his movement backward, and it's a moment where your elf will have his sword swing like this, and then he will go back like that. And so everything is independent, and everything is based on this virtual clock. The idea is that we display the first image of the animation until we're told to do something else. So if one unit has a very long wind-up time and start at minus 500 milliseconds and another one at minus 300, for the first 200 milliseconds, the first one will display its first frame. And the animator is in charge of having the first frame, which makes sense on whole. It's possible to use, in some special cases like projectile, a transparent frame as the first frame and have it stay for a time of 0. But it's the first frame, so it works. Okay, so now I'll move a little bit on how we draw the animation, as in how we actually put it on the screen. Wesnoth is based on SDL. SDL is does not have multiple frame buffers we can swap like OpenGL. It's not a 3D engine. So what that means is that we do not have the luxury of being able to move an image in the middle of the stack of image. We can only draw on top, and we can only draw. We cannot erase, because the only way to erase is to redraw what is underneath. So if I look a little bit what it looks like, animation Wesnoth is hexagon. So what we do is we use the hexagon as a basic drawing unit. We draw per hexagon, and we decide at each redraw whether each hexagon needs to be redrawn. So it's pretty handy because if I take this unit here, it fits. So if it's animated for any reason, because for instance I click on it, so we draw its selection animation, this one needs to be redrawn and all the other ones around don't need to be redrawn. Problem arises here. This unit is in a castle. To look good, we had to push the unit a little bit upward. And as you can see by my golden pointer inside the hexagon, it doesn't fit. So when this unit needs to be redrawn, we also need to redraw this hex. And this one, because it's a little bit outside. This one seems to be fine. So to do that, the Terran engine which has basically the same problem. If you look here, this hexagon here is a castle hexagon, but it has to grow the base of the castle underneath. So what they did in the Terran engine is basically they cut every image into pieces, and they then draw the pieces on the right hexagon. So we can redraw this hexagon without redrawing this one, because the little part you see here is a different image in Wesnoth. They have been cut into thousands of little images all around your file system, and which allows us to redraw this one without redrawing this top one. Of course, when you're animating units, you can't do that. You can't do that because your units move. So there is no logical cut you can use. So we have this problem that drawing is costly. We want only redraw the hexagon that needs to be redrawn. Finding out which ones need to be redrawn is pretty complicated. Frames are not always centered. Sometimes they move, so we cannot easily cut them. And we'll see that some units are huge, and they don't fit in the hexagon at all. So, when do we need to redraw? The first case is the unit moved. Somehow, idle animation, anything that the frame changed. The frame changed, we need to redraw the frame. And so we need to redraw the hex under the frame and multiple hex if it's a large frame or if it's not centered. But since we can only draw and we cannot erase, if for any reason the hex under the frame changes, we also need to redraw the image because we've been erased. So we need to redraw the whole stack, which includes ourselves. And the last problem is frames are not, animations are not only about frames. Sometimes we need to redraw because we are playing a sound which triggers some complicated stuff. I won't go into the details, but sometimes we have those redraws that arrive because of animation. So the basic algorithm is we take all units, and each unit we ask, do you need to be invalidated? And if they, the unit will say yes, and will mark all the hex that it wants to invalidate in the engine. But if it marks a hex, then other units might suddenly realize that now they need to be redrawn because one of the hex they're covering needs to be redrawn. And if one of their hexes needs to be redrawn, we need to redraw the whole frame, and so we need to redraw all the hex under the frame. And it propagates. So when your units are packed together, it can propagate pretty fast. So if I show you here, and I use this magic sunset, you can see my my screen growing dark, except on areas being redrawn. Each redraw, we add a gray layer and we remove it. So if you see here, water is animated, so it never goes gray. Here we have a skeleton which is laughing maniacally, and which is slightly out of its hex. So it invalidates this hex, which means that this unit here needs to be redrawn, which means that all the hex around needs to be redrawn. And we see randomly other units popping out, because when they're idle, they have those idle animations where they have nothing to do, and they trigger them randomly, which causes withdrawal. But the propagation can actually be pretty bad. If I look around here, you can see that this unit is a little bit over the top. So it will be in this hex. This hex has the paw of the... Oh, no, let me lighten the thing a little. This hex has the paw of the dragon. So the dragon needs to be redrawn. So all those hexes around needs to be redrawn. So this dragon is touched. And the whole thing goes pretty far, because this dragon here touches this hex, and the dragon above actually touches it too, because except for some special cases of optimizations, our frames are square, because images are square. And it's not possible to know if a given pixel in an image is transparent or not, so we just look at the surface. So we have some, fortunately we avoid propagations to go too far with a certain number of ways. Hex animations that fit in a hex. The square is the size of this hex. Technically, the square goes out of the hex. But we can tell in this particular case if it does or if it doesn't, because in this particular case it's worth it. So if your animation is exactly inside your hex, it will not propagate. We can detect static animations. Most units don't move. Their normal attitude is not moving, it's staying in the center, so we don't propagate. And animations that are out of the screen need to be checked, because they might trigger sounds, but they won't propagate, because they're out of screen. So there is no reason to have them force a redraw of something at the other end, because they're not there. And this was my overview of the Wesnoth animation engines. The part about choosing what cool animation to play, the part about timing things, and what we chose. So now, if you have any questions, yes?
Is there some kind of, I mean, if you have one animation like in unit standing or idle,
yes,
and you click on them and call them to attack, is there some kind of transition between them, between these two animations?
Okay. Is there a transition between the animations? Some way for animation to kind of meld from one to the other? That's your question?
Yes.
Not in the code.
Okay.
What I mean is that sort of having this right is very hard from a code point of view, and will never satisfy our graphic artists. So in the code, there is no such thing. However, our artists know the frames. They know the unit, and they're very good at conventions like the last frame of any animation should go well with that, should fit in this way and be more or less this pose, so the next one can go smoothly. So that's a problem that is solved not at the code level, but at the art level.
Okay.
Yes?
If an artist wants to make a special animation with this coupled with another, you can't guarantee like a special attack and defend move for
like typically between the leader of the campaign and the big bad guy of the campaign or something like that.
Then you can't guarantee that they are
You
made
can
together.
do that, yes, because as I said in one of my slides, you can select we use something in Wesnoth called the standard unit filter. Basically, Wesnoth has this coding language for its scenario, and every time you need to choose a unit, you have a standard filter which allows you to select unit based on anything in the unit, and it's basically reusing the same code anywhere, so any event, thing like that, and including the animation engine will use those standard unit filter. And in the standard unit filter, you can filter on name and on attack. So you can reply to the fireball of the bad guy with the magic shield of water, for instance. It works. You can do that.
But how do you know? Can you meddle with the scores the animation gets? But maybe the bad guys are fighting in a forest and gets.
Yes, you can. There is in one of the criteria I gave, there was base score, which is basically a bonus you can give to a given animation. So if you're in this case where you really want this animation to play because it's the end of the scenario, the big fight and things like that, you give in plus 100. So whenever it's valid, it will be played. And because it's only valid if the enemy unit has the proper name and the proper attack, it will only work when you want it. So yes, you can tweak with that sort of stuff. That's exactly the sort of case why I added this particular bonus, because there are some cases where animation won't do exactly what you want because of those scores, and you need to adjust.
You always play only one animation per turn, per game turn.
No, hundreds.
Well, for a single unit. A single unit only gets to play one.
Still hundreds.
Okay.
The thing is, when this animation engine started, it was only responsible for animations. That is, the unit moving. And when the unit was only using its base frame, it was the drawing engine that would draw it. And if the unit had no animation for a particular engine, it was the drawing engine that would do it. Now it's reverted. And whenever any unit is displayed at any time, technically it's playing an animation. And we have special cases for one frame non-moving animations, which are images. So when if I play here, this one is playing its standing animation. When you have them moving around there, they're playing their idle animation. If I select, they'll play their selection animation and then switch back to their standing animation. So every unit at all time is always playing an animation.
Okay, so what happens when you should play two conflicting animations at the same time?
I choose.
Right, but one of them started earlier, and the other one is...
We're usually, yeah, always. You cannot interrupt an animation.
I see. Okay.
That's a feature that was added for Wesnoth a long time ago, which is actually very tricky to implement. That's why it's not here. When you move a unit, you cannot move another unit until the first one is done. When an attack takes place, you have to wait for the end of the attack before you can start giving orders to other units. So there is no risk of catching a unit in mid-air. It can't happen.
I see. That simplifies.
Yeah, that simplifies. But again, we're not real time. We're turn-based.
Yeah.
And we have undo. Well, limited undo because of game reasons. Once you have drawn a bad random number, you can't undo anymore. But we do have undo. So the problem is different. Yeah, you can't catch a unit midair, you cannot stop an animation, and that's very fortunate because if it were, you would have to draw escape animations to use in the middle of the animation to get back to the pause.
And then you have escape animations for escape animations.
Yeah. So no, we don't.
Did you build the invalidation stuff from the beginning, or was that added as an optimization later? Why not just
Both.
roll the first time?
The invalidation is a common programming technique, usually based on square, not on hexagon, when you're drawing with primitive graphic hardware, pre-free. And we
SDL
Pardon?
would have
SDL is based on those principles, yes. As far as I know, because I didn't deal very much in the low-level SDL stuff, and SDL evolved, so, but the way we draw it that way. And when I arrived, there were already some invalidation routines, but they were no way as complicated as they are now. I mean, units could not be bigger than a hex, and they would slide on very precise, so you had hard-coded during attacks. This is the zone of the attack, and all those hexes are the zone of the attack, and no question asked, you redraw everything. Now you can't do that anymore, because if the unit is bigger than hex and attacks, it means that the area and the attacks will increase with the unit.
What I mean is, you're adding a lot of complexity to the profile. Like, what is the difference in the sense?
Between
You
redrawing
just
that
throw
and redrawing
everything in every
everything?
frame.
Oh, no question. When I get something wrong in the invalidation engine, and it happened a lot, CPU load increases tenfold. Because drawing is very costly. When you do invalidation, it's just some calculation on coordinates. So it seems complicated with recursion and stuff like that when you look at the code, but overall we do very simple math in the processor. Whenever you draw, you transfer PNG data to the video card. So it's very costly.
It's not hardware accelerated, so it's all going through the CPU.
It's not. It's not as. Is it? No, it's not.
SDL.
No.
SDL can be over OpenGL, but it's at that level it's not Wesnoth, it's SDL that decides to do it. As far as Wesnoth is concerned, we're not accelerating. So yeah, we do it the old-fashioned way.
The proper way.
If I could get rid of all the invalidation code, maybe I would.
Why is only part of the water highlighted?
Because the dragon is selected.
Probably some side effects of the. Yeah, that's it. I selected this unit, so its whole area has been highlighted with the. Here, you see?
Okay.
And then it has faded back to black.
Okay.
So that's highlighted because this unit is selected. Those are hashes because they are out of the movement zone of the unit. Any more questions?
Maybe a small one on the previous question regarding the redrawing. Every terrain tile has about 20 to 30 or more images drawn on top of each other. So
Yeah.
Yeah.
it makes it really costly to draw.
Can't you cache already merged ones and somehow intern them?
We tried it, but You it's have a lot of transitions between the axes, so you don't see hexagons everywhere. There's an overlay here, but if you turn the overlay off, you don't really see the hex other than the castle inside. But well, if you don't have the transitions, then you just have hexes in different colors.
Yeah.
If I,
You could cache already merged images.
the thing is, it's hard to realize until you've really been there. But drawing the terrain underneath, it's a lot of image, and it's very complicated.
Yeah.
So you want even caching is pretty tricky. We could cache the base until terrain into one structure, but we would have to keep a huge cache of images.
Actually, can I ask a question about that? It's not related to you. Because I'm wondering if you have the transitions hard-coded, or do you have any kind of language for defining the patterns for
Complete
the
language,
transition?
nothing hard-coded.
Amazing.
I mean, and trust me, it's very complicated because if you look at something like if I go on where was it? There, tracks. If I start drawing tracks, and then I draw tracks like this, they will find the proper transitions
Yeah.
to do all sorts of mappings and make them look good. And this is not hard-coded. This is all described in the language well, it's not like animation, but it's somehow similar. As in, if I am on this terrain and next to this transition and the other hex doesn't have this overlay on it, then I can use this or this image. If not, I can use this other image.
And you also have the scoring going there.
the scoring.
Scoring like with the animation score.
No, it's there's the scoring animation is basically here to plug holes. In terrain animation, they have very little holes. Basically, the idea is you test, and you have every case covered. So, it's a very different logic because it's not the same type of work. It's not the same people doing it, and it's not the same drawing constraints. So, but we have tools to help. For instance, if you take the castles, I've said that they were split into hundreds of little images. Our graphic, our artists are totally unwilling to do that sort of job, which is logical. So we have scripts that take an image and just chop it around the proper way, and then put everything into the proper places. I'm not sure if was it you who did the macro? No? It's been done some time ago. I don't remember who did it. But it's, yeah, the thing is, when you put some complicated terrains next to each other, that will, if you take this one, the chassis, see, they will always overlay next to each other. So when you have this next to it, the order in which you have to throw the base one, then the chassis and border, then the railroad on top is a bit complicated. If you had bridges, add bridges on the top, it gets even more complicated. It's important to notice something else. If I take, do I have a castle available somewhere? That's what I do. Here. When a unit is drawn in a castle, there are walls.
Yeah,
And in a typical medieval type perspective, our units are behind the walls. So it means that you have terrain, units, and then you have those borders. But the borders in the back must be behind the unit, and the border in the front must be in front of the unit. But the borders in the back are in the front of the unit behind. So that's what we describe when we say that Wesnoth's engine is 2.5D. It's completely 2D, but we really need to understand how is the 3D and how is the 45-degree perspective on the screen to know in what order we need to describe the whole thing. Other questions? Well, thank you everybody.